All right, I'm going to go ahead and get started now.
Okay.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning. My name is Mike Brumley, and I'm a Chapter Co-Vice President of the DBA Fundamentals Virtual Chapter. And today we are in our first meeting in February for the DBA Fundamentals Chapter. And today's presentation is Virtualization 101 for SQL Server. It is presented by Joey D'Antoni. I will give it to him in just a few minutes, but I want to clean up some housekeeping. The past is starting to focus more on business analytics, and there is a PAS Analytics Conference scheduled for April 21st and 22nd in Santa Clara, California. If you would like to get involved with this, you can save $150 on the registration by using the registration code DBAFCDF. Again, my name is Mike Brumley, and I want to also tell you about how you can contact myself or any other member of the Fundamentals chapter, leaders of the Fundamentals chapter. You can go to fundamentals.sqlpass.org and go to the About Us tab, and you can send us emails if you have any questions. On the 17th of this month, Glenn Berry will be presenting Dr. DMV's Troubleshooting Toolkit. Be sure you sign up for that. It should be a very informative presentation about DMVs. This session is being recorded and will be available in our archive session within a week. You also can subscribe to our YouTube channel, DBA Fundamentals, and you will be notified as soon as the recording is uploaded. That's all the housekeeping I have for today. So today we have Joey D'Antoni again. He is a senior architect and SQL Server MVP with over a decade of experience working in both Fortune 500 and smaller firms. He is currently the solutions architect for SQL Server and Big Data for Anexinet. I don't know if I spelled that or said that correctly.
And that's actually changed, but I'll cover that.
Okay.
I can take over from here, Mike. Thanks. I appreciate it.
All right, no problem.
So welcome to today's Virtualization Fundamentals for DBAs. I'm Joey D'Antoni, like Mike mentioned. And I'm currently Principal Consultant at Denny Cherry & Associates. I just switched jobs at the beginning of the year, so I think they had my old bio. I talk a lot about this stuff, and I want to make sure you can restore your data. I always like to say that. So test your backups, but always test your restores, because that's how you keep your job as a DBA. You can find me on Twitter at jdanton. That's probably the best place to reach me if you have any questions. My email is joeydantoni@joeydantoni.com. I'm a Microsoft MVP as well as a Dun & Bradstreet MVP. So let's get started. We're going to kind of take an overview of the major players in the virtualization space. Most of you that are working on virtual environments are probably using VMware or Hyper-V from Microsoft, but we'll kind of walk through some of the other players. There's a lot of different terms you're going to hear around virtualization, so we'll kind of walk through some of those and give you some understanding so that if you're working with your VM team or your server admin team, you can speak to them and speak their language. There are costs and benefits around virtualization. Nothing's free. We are getting some benefits, and one of the reasons why virtualization has become so big in the SQL Server space in the last few years is it's really the only good deal, and I use quotes around that, in SQL Server enterprise licensing. When SQL Server went to core-based licensing, that kind of made everything a lot more expensive. Virtualization is one of the few places you can get some benefits. We'll talk about the underlying technology and how that works. And then we'll talk about optimizing SQL Server for a virtual environment. There aren't a ton of things you need to do, and more so it's things you need to do to the virtual environment to get it ready for SQL Server. So the major virtualization players. VirtualBox is if you want to just get started with learning about virtualization and play with something on your own, it's more of a desktop software that was something that was owned by Sun Microsystems, but now it's owned by Oracle. Red Hat has Overt, which is a pretty robust solution, but it's mainly focused around Linux, and it doesn't have wide-scale adoption. The two main players, and really I think the only environments I've seen SQL Server run on are Windows Hyper-V, which started in around Windows 2008. It was really, really bad in releases 1 and 2, which were Windows Server 2008 and 2008 R2. It got significantly better in releases 2 and 3, which were, or 3 and 3. In 2012 R2. There's been a lot of enhancements to clustering to support Hyper-V, and the price is right, which we'll talk about later. VMware is probably the most common. I'd say this is probably 80% of the virtualization environments I see. They just announced VMware 6 yesterday, and we'll talk a little bit about some of the impacts it's going to have, because there is an impact to SQL Server that we'll talk about there. And then the last thing I'd like to talk about is OpenStack. You may hear of OpenStack. They're run by a lot of cloud providers. I think Rackspace is using them. Amazon kind of does their own thing that's built on top of Citrix, but OpenStack's an open source consortium that's working to build a large cloud type environment. So why did that happen? Back in the good old days when SQL Server licensing was cheap and we could buy it either by the socket or by the server, even if we had a CAL licensing. We had a lot of SQL servers. So we had what was known as SQL Server sprawl. So in the 2000s, late 2000s, we started trying to consolidate SQL servers because we had them all over the place. And something else happened. Our application server environments also started to sprawl. Each new project needed its own app server or a stack of apps or servers, and we ended up with server rooms that looked like bad subdivisions. So we had lots of sprawl. And that led to things like servers needing more power, and servers got more power hungry in recent years. The first time I gave this presentation, I talked about how servers started coming with 750 watt power supplies, which is a lot of power. Well, just yesterday I spec'd a server for a client, and the required power supply was 1,100 watts. I ride bikes, and a really good cyclist can put out around 400 watts for about an hour. So that's that would be 3 world-class cyclists on bikes to keep your server powered for an hour. We also got SQL sprawl. So there were a couple ways we could address SQL sprawl. We could consolidate into physical servers with lots of shared applications. But that gets kind of messy, because if we have a lot of databases all sharing the same environment and we need to take that SQL server down for patching or anything else, it can become a real challenge. Plus, managing performance between multiple applications is also a challenge. The other thing that we ran into is servers have gotten way more powerful. We can get a whole lot of server for $20,000. Like I mentioned, that server I spec'd yesterday, it was a physical server for SQL Server, so I went really low in the core count, but it had 8 cores and 756 gig of RAM, and it was a $20,000 server. So servers are really powerful. We've had massive increases in CPU performance in the last decade. All that leads to underutilized computing. So we had lots of servers that just weren't being utilized. So virtualization gives us the ability to get better utilization out of those servers. The other two things, virtualization is dependent on SANs. I know we love and we hate SANs at the same time, but they've become more broadly available in the last decade. And lastly, cloud computing. So cloud computing is something that's made virtualization develop more rapidly. I can definitely tell you, you can thank Azure for most of the advancements in Hyper-V. Microsoft went from not only being a development shop to being an operations shop, so they're more like full-time DBAs now. And so when they had to build that Azure infrastructure, Hyper-V saw a lot of improvements because they're having to support it. So those are some of the things we've seen that have led to where we are in modern computing. Some VM terminology. These are the fundamental terms you'll want to use or hear your VM admin talking about. The guest is the virtual server. So if your VM is known as a guest, this runs underneath the physical host, which is the physical machine that your VMs are going to run on. And then the hypervisor, which is either VMware ESX or Hyper-V. And we'll talk a little bit more about hypervisors later. But Hypervisor is just basically a low-level operating system that does things like perform load balancing and ensure resources between the guest operating systems. So some other terms, and we'll talk about these in more detail as we move on, but thin provisioning is a way we can over-allocate things in our virtual environments. We can actually over-allocate. We can allocate more memory to guest VMs than is physically available in the server, and the hypervisor manages this by sharing memory between the VMs as they're needed. As you might imagine, that can be a really bad thing to a production database server, so we'll talk about how to work around that. The way it does that is by deduping some of memory. So even though that process isn't really good for our database servers, it can be really good if you're using virtualization to host, say, desktops, where everybody's running the same version of Windows. Most of their memory is going to be the same, so you can get a really good footprint in memory. vMotion and live migration. This is one of the ways indirectly that VMware and Hyper-V provide mobility and high availability. So in the event of hardware starting to fail, as long as the hardware doesn't fail hard, your VM will be moved from one physical host to another dynamically. There's no downtime with this, and there's also a high availability functionality, whereas if you lose a server completely, your VM will also be migrated. These are pretty handy, and they happen, like I say, they happen dynamically, and your applications don't notice. It does make performance troubleshooting problematic, though, because if you're just running on one host with other VMs on it, and you got moved to another host with a different set of VMs on it, it can make things a little bit challenging, but we'll talk about how to monitor that later. There's a snapshot. There's a term known as a snapshot, and just to be very clear, a snapshot is not a backup, so it's not a crash-consistent copy of your databases. What a snapshot is an image of your VM. So you have a VM, snapshot it, and all the changes will be tracked to that snapshot in a Delta file. So these snapshots can grow very large, particularly in a database server, so you want to manage them. But they're really handy for upgrades, patches, and code releases. So if you're upgrading to a new version of SQL Server, you're patching, and you want to protect yourself from before, shut down SQL, take a snapshot, and then apply your patches. And then cloning is another real benefit. I used to work at the cable company, Comcast, for those of you who don't know, and we built out a private cloud environment, and we had a gold SQL Server image. So every time we built a new SQL Server, it was built exactly the same as all my every other server in the environment, and it got built in like 6 minutes. So we were only able to do that through VMware's cloning technology. So that was really pretty nifty. So cost. This does all cost money. VMware isn't free. Their licensing metrics weird, but it's related to memory and cores. It's also it's a fairly expensive product, but it's one of the few products I've ever worked on that you can say pays for itself, because you can quickly do the math as to not rolling out more physical servers and rolling out more virtual. Hyper-V is included in the cost of your Windows licensing. So the amount of VMs that are supported vary on the addition of Windows Server. So if you're on Windows Server Data Center, you have unlimited VMs. Windows Server Standard, you get 2 VMs per license, and you can stack those. However, Hyper-V by itself doesn't include a lot of management tools, and this is where Microsoft's making money on it. You really need to buy System Center Virtual Machine Manager if you're going to roll this out in a heavy production environment. So Microsoft isn't free either, but it can be cheaper than VMware. So what are our benefits of virtualization? Here's what you're going to gain. You get much higher density of servers. So your CIO is going to like it, because your power and cooling is going to get reduced, and the servers you have are going to be utilized more heavily because you're running multiple workloads on them instead of just running a single workload. I'll show in a few slides how this works, but this can be used for high availability solutions. And you can even, there is disaster recovery built into a lot of the virtualization solutions. You can have a new server built in less than 10 minutes using templates and cloning. Like I say, what we did, you can have a Windows server with SQL installed and your best practices implemented, and it will still spin up while you're getting coffee. And it's also a great place to park an app that requires a legacy of version of Windows or SQL Server. So if you have an app that requires SQL Server 2005 or even SQL Server 2000, 2000 is a challenge because you have to find an OS that you can install it on. But the other thing I really like to use virtualization for is when you have a vendor app and the vendor app asks for some off-the-wall security requirements, like the application has to run as SA or they need some goofy security thing, you can create a VM and isolate that database instance away from everything else. And snapshots can be a real benefit for upgrading, like I mentioned. So here's how this is a pretty simplified example of a server running 3 VMs. Host, like I mentioned, always refers to the physical box. You install the hypervisor on the host before you do anything else. And it manages host resources such as memory and CPU amongst the guest servers. In this case, we're running 3 guest operating systems. This could be any version of Windows. They could all be different. It could be Linux, mix or match. It doesn't matter. And typically the way this is implemented, because as you could see, if we had one physical server failure here, we'd lose 3 virtual servers, which would be pretty bad. Typically, this is implemented in some sort of a cluster format where we have multiple physical servers in a cluster supporting multiple VMs. So the hypervisor does a number of things. The guest operating systems are basically operating out of a resource pool. So it's allocating CPU and memory resources between them. One of the things it may do is move a guest operating system from a host that's at very high utilization to a host that's at very low utilization. This process is basically seamless. There are a few seconds of degraded performance. Also manages high availability. Backups can also be managed through the VMware layer. This is where the backup takes kind of a snapshot of the VM, but it is more of a crash-consistent backup. So if you're using that kind of technology where you're backing up the VMs, you will want to back up your SQL Server databases to the file system. So you'll want to write your database backups to a local drive and then let the VM backup capture those backups. So interestingly, this technology dates back to the 70s. Virtualization is not a new technology. These types of hypervisors were detailed in a paper in 1974 that was entitled Formal Requirements for Virtualizable Third-Generation Architectures. So a lot of this goes back to IBM stuff that was developed for the mainframe in the 1960s. And it kind of went away for a while. It was always around in Unix. Sun and HP both had some virtualization technologies that I worked on throughout the 90s. But now, I don't think it was ever as widely adopted as it is now with VMware and Hyper-V. There's 2 types of hypervisors, and where these are going to be very different is Type 1 hypervisors are native. So you install your hypervisor before you do anything else, and this is the case with VMware ESX, which VMware ESX is a Linux-based hypervisor, and then Hyper-V, which is a Windows-based hypervisor. Type 2 runs as a process under a local operating system. So I'm presenting to you guys from a MacBook right now. I have VMware Fusion, which is the Mac version of VMware Workstation, and VirtualBox is a very similar product. These are both things you install on your operating system after the fact. Type 1 hypervisors are going to be much more efficient in their use of memory. So if you're running on a Windows machine, if you're on Windows 8 or higher, you can run Hyper-V. That was a nice add to the operating system. And if you are playing around with this, I probably recommend running Hyper-V because it's much more memory efficient. One of my old laptops had 8 gig of RAM, and I was really hard-pressed to run 3 VMs in any other solution that wasn't Hyper-V. But Hyper-V was very effective at balancing memory because it was a Type 1 hypervisor. Anything else is going to run on top of the OS and is competing with other stuff for space. So Hyper-V is definitely what I'd recommend for your playtime, and it's free. So here's a little bit more about the architecture of what VMware looks like. We have a VMware vCenter server. The vCenter server does support SQL Server, or does run on SQL Server, excuse me. All the metrics and all the metadata about your VM environment is maintained in that vCenter database. ESX is the underlying host, hypervisor. We have 3 environments, a bunch of VMs. It doesn't really matter where those VMs are on any one of those servers. DRS is VMware's multi-site disaster recovery solution, which does require some sort of SAN replication, but it can provide a high level of disaster recovery, so it can move your VM from one site to another. And they just announced some pretty intense enhancements to it with vSphere 6, but they just got announced yesterday, so I don't have too much covered there. HA, which we'll talk about on the next slide, protects you in the event of a failed server. And then vMotion is the resource balance. So this is a picture of how the high availability scenario works. In the event of a pure hardware failure, so your memory goes down on a server, your VMs will all get moved to other host servers in the resource pool that you've created. So this resource pool is just an aggregation of physical boxes. In the event of a hardware failure, your server will go down and come back up on another node. One thing I'll mention is reboots are really fast in VMware compared to physical, so you'll be down, but you won't be down for very long. What this doesn't protect us against, though, and we'll talk about this a little bit more later, is it doesn't give us the ability to do things like rolling upgrades to SQL Server or Windows. So we can't, like we could with the SQL Server failover cluster, where we could minimize our downtime. If we're patching, we're going to have to take the downtime. Just something to think about if you're planning a virtualization environment. So the hardware we'd run for VMware Hyper-V are very similar to what you'd run on the SQL Server boxes. Standard 2-socket x86 servers, lots of RAM, pretty much all the RAM. You're going to want to max out the RAM. It's especially if you're using databases, RAM is going to be your biggest bottleneck, along with storage, which we'll talk about a little bit later. CPU is not the biggest bottleneck, but it is critical. And when I wrote this, I said it was important to be on the newer processors, which have better support. However, if you're buying a server since like 2010, they're going to have pretty good virtualization support. So that's a little bit less of a consideration now. One of the interesting things, I mentioned database licensing, and I'll bring it up real quick. SQL Server in 2012 moved to a core-based licensing model for Enterprise Edition. So that means you have to license Enterprise Edition by the individual CPU core. And it's roughly $7,000 a core. It's a little bit less than that, but that makes for easier math. One of the only deals, like I mentioned, is using a virtual environment. So in a virtual environment, we have 2 ways we can license SQL Server. One is to just license each virtual core we use, which means we're licensing each individual VM just like it was a physical server. The other option we have is to license all of the cores in a given physical environment. So say we had 4 or 5 servers, physical servers, and we licensed all of the cores. So if each of them had 8 cores and we had 5 servers, that would be 40 cores worth of licensing. So 40 times 7. That's $280,000. If we do that, and we have software assurance, that's the key to this. You need software assurance. You need software assurance for just about everything now. Then you can run unlimited VMs. You can run as many VMs as you can put in your environment running SQL Server Enterprise Edition. So I've worked with a number of clients that have done that, because say it's the only quote-unquote deal in SQL licensing now. But it's just something to take note of. So snapshots. Snapshots are a wonderful technology that's built into the virtualization solutions. Both VMware and Hyper-V have them. In a nutshell, it's a way of rapidly doing a full backup of your system. You may have seen something like this with SAN, but with SAN snapshots. It's very similar technology. The hypervisor takes a block-level snapshot of the guest operating system, which is very small. So initially, it's just a picture, and then it tracks changes in a snapshot file. Don't forget if you take a snapshot, because particularly in a busy database server where you're making a lot of changes, that snapshot file is going to grow very fast. But this is a really great thing if you're patching, doing cumulative updates or service packs. code deployment, or even Windows updates. But generally, I limit Windows updates. I'm less concerned about failing as I am SQL updates or code deployments. So the one other thing to note is that snapshots are not crash consistent backups. So if you're in an environment and your VM admin's telling you you don't need to take backups because we're doing snapshots of your VMs and you have databases, he or she doesn't know what they're talking about. VMs, it's just a block level. So SQL is still running at that point, and SQL is still reading and writing. So you're still going to want to, even if you're using snapshots, even if you're using some sort of VM backup technology, you still need to back up your database in a consistent manner. This is very important. And like anything else, always test your backup process, and more importantly, test your recovery process. Thin provisioning was something that kind of came to us from the storage world. Your SAN folks do this as well. It's not just the VM folks. In a nutshell, the way it works, in a SAN environment anyways, if you ask for a 100 gig drive, thin provisioning may only give out 10 gigabytes until you need it. So this is kind of like commodities trading a little bit. And much like expanding a data file in SQL Server, if you don't have instant file initialization turned on, is a very expensive task. Expanding a disk is also an expensive proposition in terms of performance. But we can over-allocate a bunch of things in VMware. We can over-allocate memory, and we'll talk about how that can be a negative effect. I had one client who didn't have their memory configured correctly, and I was looking at their server, and page life expectancy was about 7,000, and then I ran the query again, and it was 15. And we'll talk about how to avoid that in a couple of slides, but that's what can happen if you over-allocate memory. Management console, and really, frankly, the VMware training encourages this, but it's not really good for production servers. So for your production environments, you want everything fully allocated. Just keep that in mind. And you can treat dev and QA a little bit differently. You can save some space there. But for production, you want everything fully allocated. And we'll talk about memory as well, because the memory can be shared, but you don't want to do that for production. So I always like to talk about this being a shared environment versus a multi-tenant environment. So on the left, we have a lovely house in the English countryside. Your closest neighbors are probably a mile or two away. So it's fine to go out and play drums at midnight. Nobody's going to hear it. On the right, we have a high-rise in Manhattan. So the equivalent to the house on the left is a physical dedicated SQL server for your application. You can do what you want. The thing about the dedicated environment is that it's pretty easy to monitor. You know you're only using SQL Server on that box, so that's pretty. You know what to look for. You're looking for things like page life expectancy, CPU use. On the right, your neighbor could be the Exchange server, which is going to be really impacting to your performance. The Exchange server is kind of like the neighbor who wakes up at 1 a.m. and starts drumming really loud. And you can be doing the same thing to your virtual environment, like when you run CheckDB on Sunday. You can degrade the performance of the rest of the environment. So that makes it a little bit challenging. So how do we do this? Virtual environments, by definition, are multi-tenant. It's like living in that big building. You don't want to have noisy neighbors. The big consideration here is it can make your baselining and monitoring processes a lot more challenging than just a straight physical server. This can be a little bit political, especially in large organizations, but always ask for view access into vCenter. Always fight for it. I can't tell you how many clients I've gone to where the DBA team didn't have access, and I'm like, you really need to have that access. If you don't know what's going on in the virtual environment, you don't understand if all of a sudden SQL Server performance just dropped dramatically. It could be because you just got vMotion to a different host, and you really need to have visibility into that. One thing, and I'll shill for a vendor real quick, because I think they have a really great tool. SolarWinds, it used to be Confio, has a tool that allows you to correlate your SQL Server wait stats with events that are going on in the virtual environment. That's a really nice tool that does a lot of this work for you. But you'll definitely want to ask for access into your vCenter environment. It really is critical. And And that way you can see what server, as you can see what servers are sharing your environment, what you're running alongside. And as your environment grows, you may want to have a dedicated cluster of VMware for your database servers. This could even be the case if you're using that licensing model, that you have a dedicated VMware cluster just for SQL servers. It's not a bad solution because then you can kind of align workloads and do some other things. So let's talk about vCPUs. CPUs can be overallocated. What this means is you can grant more CPUs to VMs that are physically available to the box. This is a really bad idea under high loads. For development, it's less of an issue. Another interesting thing to note is VMware gets less, and this is true for Hyper-V as well, gets less efficient as you add CPUs to servers. Their ideal number is 4, but because they're virtualizing this and they're having to do things like schedule operations on the CPU, each processor you add becomes progressively less powerful. So, and the other thing to mention is you really want to be careful on how much CPU you allocate, because there are pretty dramatic performance decreases if you over-allocate CPU. So I always like to start out with 2 CPUs when I'm building out virtual machines, just because over-allocation isn't good. You get the newest servers that you can get. That just kind of goes with anything. And on production VMs, you should only have a 1-to-1 ratio of vCPUs to cores. You can also reserve CPUs in VMware so that they aren't allocated to VMs. I haven't done this too commonly. It's done on memory more specifically, but it's something to think about. One other thing to think about, and it goes a little bit beyond of how deep I wanted to go, VMware is NUMA aware. So if you have very wide VMs, that is VMs that have more CPUs than you might have in a given socket on a server, there are some different things to keep in mind. But if you have any questions about that, ping me offline. But yeah, just know that there is vNUMA and you can configure it. So through the magic of VMware, we can over-allocate memory to servers. So much like CPU, what it means is we can allocate more memory than is physically available. Never, ever do this in production. It's bad. I told a little story about my client earlier. So yeah, I was troubleshooting some performance problems they were having, and I knew they were running on a virtual environment, but I hadn't thought to ask all the questions yet because I was just there. And page life expectancy, which if you're not familiar with it, is a metric in SQL Server of how long a given page of data is expected by the optimizer to live in the database cache. The old value that we wanted to see was 300. That's really low for modern servers, but that's kind of a different topic. Anyway, this client had an acceptable page life expectancy. It was right around 5,000, and it was holding pretty consistent. And it's something you track over time, so I kept checking it from time to time, and then all of a sudden it dropped to 10, and I was like, what the heck? And then I remembered it was a VM. So what happened was the balloon driver, which we'll talk about on the next slide, came to Windows because other servers needed that memory, and took it away from my SQL server. The hypervisor makes a call to the guest operating system and says, hey, I'm moving memory away from you. And then all of a sudden SQL Server doesn't have that memory anymore because Windows took it away from it. As you can imagine, this can have dramatic impacts on performance because memory is always our fastest part of the system. So just remember that. And so that's kind of how the balloon driver works. And I always like this picture. This is from the movie Up, but this is the balloon driver can take your house away. It is that evil. What the balloon driver actually does is reclaims memory from guests that VMware thinks aren't using it. So memory overcommit is exactly that. The hypervisor promises more RAM than it can actually deliver. In most cases, VMs have been allocated more RAM than they actually need. So this isn't an issue. The balloon driver comes around and deflates the actual usage, but it's kind of an ugly process. There's a couple of things you can do in this. we'll talk a little bit more about locked pages. I don't always recommend using locked pages. The real thing you want in production is to have your VMware admin set a memory reservation for your server. That will guarantee that your server will always have the amount of memory it has. They're not going to want to do this because it doesn't let them get as much density as they'd like, but if it's a production database server, it really needs to have a memory reservation. And then lastly, if the worst thing that can happen here is if the balloon driver can't deflate some of the memory from other servers, VMware itself, ESX, will start paging. And what it'll start doing is transferring the contents of its RAM, the physical RAM on the server, which you can access in nanoseconds, to the turtle slow milliseconds of disk, and make guests access their RAM from disk. So this is really, really bad. You don't want this to happen. So I say always memory reservations on your physical VMs, or production VMs, not physical VMs. So storage is a key concern, and we can imagine why. When we had one server per box hitting the SAN, that's not that much traffic. Now that we have tons of servers hitting the SAN, that we can have definite traffic. And SANs have gotten better, and we'll talk about that in a few slides. So there are two types of file systems in VMware. This is less of a choice in Windows, Hyper-V. We have VMSS, which is the VMware file system, and raw device mapping. Performance between the two is similar. You lose a lot of the cool benefits with raw device mapping. So you lose things like snapshotting. You lose a lot of the really neat VMware advantages. The main reason we used to have to use raw device mapping is if you wanted to build a Windows or a SQL Server failover cluster, raw device mapping was a requirement. That is no longer the case as of yesterday. So if you're using VMware 6, you can have SQL Server failover clusters in VMware. Performance is similar. There are some other weird limits around RDM. Now that, frankly, we can use VMware file system for SQL Server clustering, there's almost no reason to use raw device mapping that I can think of, at least in a Windows space. And VMware is really trying to get away from the use of that because just the limitations. This is always going to be a shared storage environment to get high availability in DR. We'll talk about something with Windows Server in a few slides that Hyper-V does. VMware has something similar now, where VMware calls it vSAN, and Hyper-V calls it storage spaces. And this is where, instead of having a bunch of servers with very little local storage attached to the SAN, all of our servers that are serving up our VMs are loaded full of physical disk, and VMware or Hyper-V does the SAN management. So that's kind of an interesting technology, and I see it moving forward pretty rapidly. I know it's what Microsoft's probably using internally for Azure, so I think we're going to continue to see those trends develop. So the SAN isn't dead, but they're making strides in that direction. So partition alignment still matters in a virtual environment. That matters only less than Windows 2008. That's fixed. Work with your storage team to monitor your I/O. You may see when you move to a virtual environment, your I/O wait times increase. This could be because of traffic. It kind of depends on what kind of SAN you're on. A lot of times, things that you would think would be sequential I/O, for example, log writes or table scans, end up coming out of VMware looking virtual or looking like they're random to the SAN. So just kind of pay attention to those things and work with your SAN team. Data storage. So it can be easy to overwhelm storage if not enough devices are presented. What really changed is modern SANs. And this is probably for the last 5 or so years, we've really started to see the SAN architecture shift. If we think back to SANs and we think of LUN, which is the LUN is a volume that gets presented to your server from the SAN. That used to be really just like a series of disks that were on the SAN, and you got something that was carved out of that. The way modern SAN architectures work now is the entire SAN is striped across all the disks in the array, So you're presented a group of like 1 meg or 768K, depending on your SAN vendor, chunks of disk that are all presented as a single physical disk. The other trend in the architecture that we've seen is the use of solid-state storage. So sometimes we'll have dedicated solid-state arrays if you're working for a really rich company, because those are awesome and go fast. In other cases, we'll have a tier of solid-state in an array. And the SAN will move hot blocks, so those extents or chunks we talked about, it will move them between tiers of storage. So it can move them from, you know, the spinning disk to the solid state. So modern SANs tend to be better. So if you're trying to implement a virtual environment and you're on a really old cheap SAN, like a old dull EqualLogic, you're probably not going to be really happy if you're trying to throw high performance workloads at it. So storage is probably the most critical part of any virtual infrastructure. I mean, it's always our biggest limiting space in database performance, but it's definitely part of the problem in a virtual environment. So Windows Server 2012, I kind of talked about this a couple of slides ago, but I'll go into a little more detail here. It introduced this concept of storage spaces, and this allows storage to be pooled and shared between multiple VM hosts. And this is our local storage that's running on the servers that are our VM host. And this can also be created from servers that are running on non-Microsoft platforms, which I found kind of interesting. That was even before Satya was CEO, but we can go across platforms. So here's how this looks. We have a storage pool. We see individual physical disk. Starting with Windows Server 2012, we can create tiers, and Windows is smart enough that it will migrate blocks between tiers of storage. So this can be a really powerful feature to be available. VMware has a very similar product. It's called vSAN. It was introduced in the last release of VMware. The one thing to consider is if you're using a solution like this, and this really goes to your virtualization admin, but you're going to have to allocate a little bit less resources, so you're not going to quite get the same density, because all of this stuff we're talking about, like snapshots, this virtual SAN stuff, any additional technology that the virtualization solution or your hypervisor is doing, your hypervisor is obviously going to need more CPU and memory resources to perform that computation. So pretty basic, but just something to think about. So here's our virtual server, and let's talk about how to virtualize SQL Server and what we use differently. So a couple of things. I say use traceflag T834. That's a VMware recommendation. Only use traceflag for large pages, and make a note of this to ask your infrastructure team if you're using large pages throughout your SAN environment. So all your switches need to support large pages, and your SAN needs to support large pages. If this is the case, definitely use it. If not, it will bottleneck to the slowest, and it won't be worth using. So think about that one carefully. Email me if you have any specific questions about it, and I'll start answering questions in a few minutes. Reserve memory for production workloads, and I thought this was so important. I added 2 bullets for it because I say also reserve memory in hypervisor for prod servers. So make memory reservations. That's the total case. I say follow the same storage best practices you would for a physical box. I like to do this logical separation, and I present separate volumes for temp DB data and logs. It really depends on your SAN architecture there, and really how much throughput you have. There are some considerations, in not going too much in internals. Depending on how you configure this, you can get a lot better performance by structuring it to separate devices, but it's really in a depends scenario. So from a storage perspective, I don't like to change too much from how I configure a physical box. Baseline your I/O performance. So if you're moving from a physical to a virtual environment, get a good idea of what your file wait stats are and what your latencies look like before you move to a virtual environment, because the I/O subsystem is going to likely change, and the paths they're taking are going to change. So that's something to think about. I always like to say think carefully about using lock pages in memory. I know a lot of people recommend it. I prefer memory reservations as a technology. Lock pages of memory can have some other downstream effects. I always like to enable optimize for ad hoc workloads for SQL Server. What that does is reduces the amount of cache that's used for query plans and gives you more cache for data. I always try to like to say, if you're working in a virtual environment, just assume you're not going to have great I/O performance and tune that way. So kind of what that means is tune to a more index-heavy environment, optimize for ad hoc, and then don't over-allocate CPUs. This is also a really, really bad thing for your virtual environments. From SQL Server, monitoring things basically stay the same. Where this gets tricky is CPU and memory counters don't always work right. VMware does install some additional performance counters, but always ask for access to the vSphere client. It's the only way you can have broader overview into what's going on. You really want to see, if you're checking things like CPU and memory utilization, you really want to see what's going on at your host and not just within your VM, because otherwise you can't really tell. So if you're troubleshooting a performance issue, just troubleshoot as you normally would, and then check VMware. So similarly with like a SAN, you want to see what apps are sharing your resources. And you're also going to want to look at the storage environment. And you can always vMotion your server off to another physical machine if you have to, or use live migration if you're on Hyper-V. So virtualization is here. It's something we get used to, and remember, virtualization powers the cloud. So if you're using Azure, all the stuff I mentioned applies. You just have way less control over the broader environment. And remember, you're working from a shared resource pool, and that can impact your workloads. The biggest thing I can say from changes you need to make to your virtual environments is tune to having bad I/O generally, but understand and have a good baseline of your SQL Server performance before you move to a virtual environment. Don't over-allocate CPUs. So I almost always recommend customers reduce their core count. So if you had eight cores in your physical server, I recommend starting with 2 or maybe even 4. Unless you're CPU constrained, more CPUs will hurt you. And then get access to your virtualization management layer. I can't emphasize that enough. So let's go out to the GoToMeeting and take some questions.
Hey Joe, you want me to read them off, or do you?
I got them. So I see you're showing the resource monitor. Is there a way to freeze the CPU in network windows? That's my resource monitor. Sorry, I was doing something in the background. Get to the next. With cloning a SQL Server image, how do you keep changing of server names, etc., internally so it's separate and doesn't keep the original names and IPs from the original? That's a really good question, Heather. So here's how that works. You have an image of your VM that's got SQL Server installed, and then you run something that's called sysprep from Windows, and that resets all the SIDs and the GUIDs and things like that. Then you actually rename the server and join it to the domain. The one change that needs to be made to SQL Server, so all that's handled from a Windows perspective, and if you email me, I have some PowerShell code that I can share with you. You can email me at jdanton1@yahoo.com. From a SQL Server perspective, SQL Server doesn't really care about the rename. The one thing you have to do is do an SP drop server and add server with the new name. So I have some code that does that programmatically, that passes that in. But that's really the only thing SQL Server cares about. Everything else is typically handled from a Windows perspective, but it is scriptable through sysprep. To take a snapshot of a SQL Server, are there any recommended best practices other than shut down SQL Server before taking the snapshot? Thanks, Patrick. Another good question. No, not really. Shut down SQL services, take the snapshot. The big thing is that you're going to need to delete the snapshot relatively quickly after you use it, because it will grow, much like a SQL Server snapshot would. As you read data, it's going to grow. Likewise, as you read and change data, the snapshot's going to grow in the virtual environment. So that's the key thing there. I'm reading the book Virtualizing SQL Server on VMware, and I'm not sure it's a good resources. There are some errors in that book. What resources do you use for setting up SQL Server on VMware? Basically, what I covered, it's not that different from a pure setup perspective. The big things are not to overallocate the CPUs, and really just pay attention to your monitoring. So when we built out the private cloud environment at Comcast, I don't think we made any changes, any real configuration changes from our physical build, except that we changed, lowered the CPU count. Aside from that, we pretty much did everything the same. Can you set up clustering in VMware or Hyper-V? I'm going to answer this question from two approaches. You could always set up always-on availability groups because they had no requirements for shared storage. You can set up SQL Server failover clustering in Hyper-V, and you've always been able to do that. I think Alan Hurt may have some blog posts around that. I haven't set it up in a production environment using Hyper-V. I've set it up on my workstation. VMware required the use of raw device mapping for clustering before VMware 6, which was like just released yesterday, and now it supports it in VMFS, which is VMware's file system. So yes, clustering can be set up. A lot of people use always-on availability groups though, just because shared storage and virtualization gets complicated. What would be the symptoms of an over-allocated CPU? Basically laggy CPU performance. It's really something you'd have to monitor from the VMware perspective. It's a little bit harder to monitor from inside of a guest. And how to find and resolve performance issues in a virtual environment. Like I say, just like you would on a physical environment, like the example I gave about that client with page life expectancy. I was just monitoring their page life expectancy, and there are certain symptoms you'll see that can be indicative of weird performance in a virtual environment. That one being a prime example. If you see something like CPU goes crazy all of a sudden and you know SQL is not doing anything, or page life expectancy drops, it's probably related to your virtual environment, and that's when you want to look at vCenter or System Center Virtualization Manager. Good question. Will setting the min and max memory in SQL do the same thing as the memory reservation? No, because the hypervisor is interacting with the operating system memory function. So even if you have max memory set, if you're not using locked pages, Windows can still take memory away from SQL Server. Also, don't set min and max memory to the same value. It can cause dramatic performance degradation and weird things to happen in SQL Server. If you search on min-max memory in books online, there's a note at the front of every page now. I know this is something people used to recommend before we had in virtual environments, before we had better understanding of what's going on. How to find out if it's SQL Server having performance issues or if it's the virtual environment? Really, the only way to do that is to look at both. So you look at your weights in a SQL Server perspective, you look at other performance metrics in SQL, and if you can't explain them through bad queries or workloads, then go to the virtual environment and take a look at that. Can we get access to slides? I'll get the slides to the guys. This is being recorded. Why separate the TempDB data and logs as they're all going to be on the same physical host? The answer to that is I made that statement assuming you're going to a shared storage environment, which most virtualization environments are. You also may want to have different, and this kind of goes beyond the scope of this presentation, but you may want to have different storage policies for each of those files. You can contact me offline if you need some more information on that, because it's a complex question, but and the answer is kind of it depends. Do you see any advantages to running a cluster in a virtual environment? The big ones you can do rolling upgrades. It used to be a real headache with VMware 6 and Hyper-V. It's less of one now. So it depends on your availability needs. Personally, I still rather go with availability groups because I don't have to set up shared storage and I can get some of the same benefits to do rolling upgrades, but your mileage may vary and it really depends on the use case. How do you handle power settings on a VM? Good question. Everything should be set to max power to use all the power. So you want good performance. Don't try to sacrifice power in your VM environments. There are some interesting things you can do with that, but we're a little short on time. Are there any advantages to creating multiple drives, separate data and log files? What advantage does if everything goes to the same data store on ESX? Not so much if you're going to the same data store. That's where you'd want to split up data stores if you're doing that. My email address is jdanhan1@yahoo.com. If there are performance issues, what should I be looking at? Dustin, good question. Do you recommend using para-virtualized drivers? Yes, and VMware does as well. Dustin, email me. I'll talk to you about that. Do you recommend using always-on availability groups with virtualization? And if so, do you think using solid state with the RAID configuration is also good? Yes, yes and yes. Kind of a complicated, long question. Renee, if you want me to, I can go into more detail if you email me. Should you lock VMware memory for SQL or keep the SQL VMware memory to unlimited growth? Lock it. And I think that's the end of the questions, and we're almost out of time. So thanks, everyone, and I hope you enjoyed it. If you have any questions, email me. This session has been recorded and will be posted on both the YouTube channel and the DBA Fundamentals website.
Thank you, Joey. I definitely want to thank you for taking your time today to share your knowledge and experience in such an understandable way. Today, the gift card winner that we have is Tammy W., and we will use the email address that she provided when she logged in to the session. And we really want to thank every one of y'all for showing up